Hello everybody, so in this video we're going to look at question 13 from page 62. So this is a question about the basics of wave calculations, where we're talking about wavelength and wave speed and frequency and period. So this question deals with the 2004 tsunami, which some of you may not remember, or even most of you may not remember, but it was a very big deal and it made international news at the time. So it starts off by telling us what happens in 2004, which is good background knowledge. One of the first warning signs was that the tide seemed to go out very quickly, and there's videos of this online that are maybe worth watching. You can see on the coastline all the water just disappears, all the water just gets sucked out to sea without warning, and obviously a much greater extent that was normal. The water just kind of seemed to be sucked out of the water as if somebody pulled the plug on the sea. So this was essentially the arrival of the trough of the wave, where the water level would be low, followed by the really high water level. The time for this varied depending on the location, but in some cases the crest arrived about 7 minutes later. The wave speed was measured at 40 kilometers per hour. So based on the figures, what was the wavelength of the tsunami as it came ashore? So what I'm going to do is I'm going to just get a solution I've pre-prepared here, and I'm going to talk you through the solution. So we have part A up the top, part B in the middle, and then part C down the bottom. So you'll notice in this video I'm going to talk to you about it using the units I used, which is, I guess, kind of unconventional. I wouldn't necessarily recommend it for a leaving cert question, but the reason why I use these units is because it will give you out the answer in the same units then that the book seemed to want them for its one, right? Now you could switch all of these into standard units and you would get exactly the same answer, and your units would just come out differently as a result. So feel free to use the same method and just convert things to the more standard units, seconds and meters instead of hours and kilometers. Okay. So anyway, the question here gives me things in terms of kilometers per hour and minutes. So, right, if they first of all ask me for the wavelength, the formula that we were given for the wavelength here is going to be C is equal to F lambda. And I'm particularly like this one because it talks about wave speed in it, and it has the wavelength as well. So wave speed I'm given as 40 kilometers per hour. Wavelength is what I need to find. So if I can find this frequency, then I'll be able to fill in C and F and find lambda or wavelength. So to try and find the frequency, first of all I just look at the time that I'm given there. They say that the water was sucked out and came back 7 minutes later. So if we look at the time being equal to 0, water would be here. 3.5 minutes later, the water will be at this farthest point out to sea. So if we want to visualize this, here's its equilibrium position where the water started off, and then the coastline gets moved out to here at time of 3.5 minutes. Then at the 7 minute position, it's come back to the shore. So it's back here, right? However, this is not a full time period. The full time period would be how long it takes to repeat one full cycle of the wave. So in our 7 minutes, it's gone out to its point of maximum displacement out to the sea, then come back to where it was. But for a full wave cycle, it would have to go from here out to its maximum displacement on one side, then back to its maximum displacement on the other side, and then back to the center for one full wave cycle. So it's going to take twice as long. I'm just going to continue doing these out. So at a time of 10.5 minutes, it would be as far inland as it's going to be, and then at a time of 14 minutes, it's going to be back to where it started, right? So that would be one full wave cycle going from its equilibrium position out to one side, back to equilibrium, out to the other side, and then back to equilibrium. One full wave cycle. Okay, so that's a time of 14 minutes. Now, because I wanted to use the units that the question is using, I'm going to express that in hours, right? So I'm going to choose hours as my amount of time that I'm putting in. I'm going to put kilometers as my unit of distance, right? So my time there is 14 minutes, my period, how long it takes for the wave to repeat itself. So as an hour, or to put that time in hours, it would be 14/60ths of an hour, right? I then did a little bit of working out, and I figured this out as a decimal to be 4.286 inverse hours because it's frequency, right? Okay, so the wave would repeat itself 4.286 times per hour. If you're putting in seconds, then your unit would be hertz, right? But a hertz is just an inverse second. There's no hertz equivalent for hours that I know of. Okay, so we've got our frequency then. It happens, the wave repeats itself 4.286 times per hour. So now we can fill it into the wave speed formula, which shows the relationship between frequency and wavelength. So we fill in our frequency, 4.286 times per hour. Our wave speed is 40 kilometers per hour, as we're given it in the question, 40 kilometers per hour. And then when we work this out, we get a wavelength of 9.333. So bearing in mind that I put in kilometers and hours into the formula, I'm going to get kilometers out then for something that's a measure of distance. Again, if you put in the wave speed in meters per second and the frequency in hertz, you'd still get the exact same answer, because you put in meters per second, your distance that you get out at the end is going to be meters. Put in meters in seconds, get out meters in seconds. The second part of this question then asks us for the time period of the wave. So half the wave motion we said takes 7 minutes, so the full period should be double that of 14 minutes. We already talked through the reasons why there, so it would have to not just go to one side and back, it has to complete a full cycle to both sides and then back to its equilibrium. Alright, then the final question says, as the tsunami moves across deep water, it would have traveled at a much greater speed, as fast as 800 kilometers per hour. What would the corresponding wavelength have been? So for this one, we again just use c equals f lambda. They've given us a new speed of 800 kilometers per hour. Again, I kept it in kilometers and hours. So I kept that as 800, and then 4.286 times per hour the waves repeat itself. And then lambdas are unknown again. So we get 800 divided by 4.286, which gives us 186.654 kilometers. Again, if you put in your wave speed in meters per second, if you converted your 800 kilometers per hour to meters per second, and converted your frequency to hertz, by putting in your time in seconds, then you would have got this out just in meters, right? You put in meters and seconds, you get out meters and seconds. So your unit for wavelength would be measured in meters as opposed to kilometers.